All right, first off, let's just talk about your vertical asymptote. Look, your vertical asymptote here, it's going to exist wherever you guys have a restriction. These are your restrictions, and on a vertical asymptote, your restriction or your boundary is your denominator when x is equal to 0. Remember, you cannot divide by 0, right? It's like undefined. You cannot divide by 0. So whenever you're dealing with rational functions, if you ever want to know your vertical asymptote, look at your denominator, make it a separate equation, and find out where it's set equal to 0. Those numbers are your vertical asymptotes. You can have 1, you can have 3, you can have 4. It just depends how much of a polynomial degree it is, okay? Okay, but we're starting off easy here. Okay, so if I have this fraction, and it's just this rational expression or function, 1 over x, and my denominator is x, right? So it's just x. So if I pull x out and I set it equal to 0, well, that just means x is equal to 0, right? So in this case, my vertical asymptote is at x equals 0. Okay, but if I now turn to the second function, if this is my function here, that's my denominator, x plus 1 set equal to 0, solve it, what value makes the denominator 0? What value will make it 0? Negative 1, right? Because subtract 1, and I get negative 1, right? And so negative 1, right? Negative 1 plus 1 gives me 0. And so your vertical asymptote here is negative 1. And so here, again, so your vertical asymptote exists where the restriction is a denominator equals 0, because you cannot divide by 0. So that is always your vertical asymptote. And so what are the more difficult problems? You're going to get quadratics or cubics, and so we have to factor. And that's why it gets more difficult, is you have to factor to get your denominator of 0. And then that's how you find your asymptotes, okay? Okay, horizontal asymptotes is a whole nother deal. Okay, we're not at the difficult part yet, okay? So we're at the easy part where we're just looking at these, okay? So here in this case, if we start looking, so like, we're going to start shifting. But here you guys have your horizontal asymptote. Okay, I have 1 over x, right? So for you, well, let me stop the video and then I'll do the other one, because that one takes a little longer actually.